Good afternoon, everyone. I see it's just gone past 3 o'clock, so I'm sure there's going to still be a few people joining, but we'll start with a bit of the formalities. So first of all, welcome to our webinar this afternoon, where we'll be discussing how to build rock-solid data foundations for a sustainable energy management, and obviously why that matters. So my name is Charl Marais, and I have with me Tineke and Claudia, who will be sharing some of their insights that they gained off of a recent project. So to start with, we will not be having any live conversations. So please use the chat provided to type any of your questions. If we do have time at the end, we will see if we can answer some of those. And if we can't, we'll get back to you at a later stage. So as a start, we're all familiar with the famous Archimedes quote, give me enough clean data and energy and I can solve any problem. And the challenge we find today is that we've spent a lot of time understanding what it means to have clean energy, but we're still sort of neglecting the idea of clean data. We're simply assuming that data is data, and as long as we have a lot of it, we can use all the modern technology like machine learning and AI and push this data through visualization platforms, and it'll work. Unfortunately, the reality is that it's slightly different. So if we look at traditional analytics and visualization projects in an optimization space, we find that we're spending the vast majority of our time during the build phase. So all of our time and energy and thinking is going into what we're building without spending sufficient time on goal setting, and definitely without spending sufficient time on accessing, ingesting, cleaning, and preparing data for these models. And then also we find that not nearly enough time is spent on adoption and change management. And as a result, there have been many studies over the last few years by Gartner and the likes that show the success rate of these projects are extremely low. And we believe that a lot of that has got to do with the data we try and use or the lack of preparation we put into that data. So as an alternative, if we had to modify this approach slightly, and first of all, we're spending more time on goal setting, which means understanding clearly what the objectives are that we're trying to achieve. We're also spending significantly more time on the adoption and change management piece, where we speak to users, we involve them in the process, the feedback gets incorporated into the solution, and we monitor the usage and incorporate all of that feedback in the solutions we're trying to build. That tends to improve our success rate. But really, none of that matters if we don't make sure that we build these solutions on a solid foundation of data. So, with me today is Claudia Kromert and Tineke du Plessis, who have recently finished a project doing exactly this. So, on this particular project involved energy and utilities, but the primary focus there was pulling in information from various sources, different meters, different databases, all these different environments that came with different levels of complexity and aggregation, and pulling that all together. And they are here today to share with us the lessons they've learned on that project. Tineke, Claudia, over to you.
Thank you, Charl. Okay. Okay, so while digital transformation touches virtually any industry from finance to healthcare to manufacturing and logistics, in this webinar, as Charl mentioned, we'll be actually focusing on energy applications, specifically the critical role that strong data foundations play in enabling successful digital transformation in energy environments. We'll walk through practical insights, some real world challenges, and proven solutions, all drawn from an actual implementation project, as Charl mentioned. So, this isn't just theory, it's grounded in experience and designed to help you avoid common pitfalls while maximizing the value of your energy data. Okay, so On the left, we have the dream, the AI models, the ESG dashboards, the automated reports, cost optimization, and real time decision making. The value data utilization can add to your organization can seem to be endless. The more you do with the data, the more you play with it, the more you demand from it, the more you get from it. It can be as though the value is directly correlated to how much you try to do with the data. So, the natural inclination is for organizations to want to do as much as possible, as fast as possible. However, in most cases, companies unfortunately completely jump the gun when it comes to utilizing data. They leap ahead into data utilization without laying the groundwork. So, why is this a problem? Because the reality is that data is more often than not even nearly ready for utilization. So, data issues can include data gaps, silos, legacy systems, poor data quality due to the lack of validations and approvals, and third party data that is not available or not integrated. The biggest problem in digital transformation is the ostrich effect. People don't want to face their data issues head on and would rather just assume that everything will be fine somehow. But if we don't fix what's happening underneath, the surface level tech doesn't stand a chance. On the contrary, the data becomes untrustworthy, and not just in reality, but in perception. And the unfortunate thing is that this perception will linger and it becomes a barrier to adoption even after the data has been fixed. So, the long and the short of today's webinar is don't skip the foundation if you want the house to stand. The value of your digital transformation project will be short lived if it even sees the light of day. Okay, so this is going to be the framework we'll be talking about, just starting in layman's terms. So we know three things. We know we have messy, incomplete data. And we also know we want to reap benefits from that data. We want to be able to do something with that data and gain insights from that data. And then hopefully we know that there's a gap to breach there. But how do we bridge this gap is the one question. And the other question is all of this worth it? Like, are the benefits of such a degree that going through this data cleansing exercise, is it worth the monetary and the time investment? Like, are the benefits concrete and measurable?
So, Tineke, to answer your question, it helps understand what a strong data foundation actually looks like. So, a good data foundation relies on three key steps. So, you have your availability, your transformation, and then your utilization, your benefits that you will reap. So, think of it as a funnel. If the data isn't available, then what are we transforming? And if the transformation is inconsistent, then what are we actually utilizing? So we need to ask ourselves, what is the end goal of what we are trying to achieve? If what is the benefit in having all of this data at our disposal, but not really know how to use it? So we can clearly see that any weakness or gap in any one of these three steps impacts the one that follows. So the whole structure becomes very unstable if only one of them is unstable. So for true value, each step must be strong and connected and also complete. So let's start where every business focusing in the energy sector tends to focus, the outcome. So what's the purpose of what we are doing? So when a project gets kicked off, the first thought that usually comes to mind in everyone's minds is, how is this going to make my life easier? So a question that often pops up is, will the system do this for me and now I don't have to do all of these tedious tasks anymore myself? Will this free up time for me during my day? It will probably sound very familiar, so let's jump in. So, what does it actually mean to utilize data at our disposal? So, it means that taking data that is actually available, it's trusted, and also standardized across systems, and unleashing that data's full potential. So, when we talk about data potential, we're not just talking about fancy reports and charts and everything. We are talking about a complete shift in how your business sees and reacts and also performs. So, because when data is truly utilized and used, the possibilities are endless, as you can see on your right. And this leads to the following. You can now drive ESG goals with precision, track environmental performance in real time, like with a live sustainability dashboard. So no more waiting days or weeks for someone to compile a scattered data from various systems into one place. So no more digging through outdated spreadsheets and guessing whether yesterday's numbers still reflect today's reality, basically. Now everything is in front of you in live and accurate and actionable. And then next up, you establish a single source of truth, so across all systems. So again, all of those scattered Excel sheets filled with very complex macros and hidden logic that probably only one person knows how it actually works and how to use it is gone. You just have your one central trusted database. So, and also that person whose dedicated job it was to manually every week build those Excel sheets and manually build the logic, that role entirely transforms from a data cleaner perspective to a strategic analyst role. So the value shifts and they can actually start to focus on interpreting the data instead of compiling it. And then next up, you can split costs accurately across multiple business units now. So with traceability down to the last kilowatt and the last rand. So for example, different sites use different tariff structures. So for instance, site 1 can use a time of use tariff structure. So depending on the time of day, the month, where winters will obviously be more expensive, the rates will differ versus site 2 that uses a flat rate. It doesn't really matter the time of day. It's just one normal flat rate throughout the business unit. And now suddenly you can track all of those meter consumptions and get the costs based on the various tariff structures. And you can now catch billing discrepancies instantly by comparing your power usage and costs, your actuals to your invoiced costs and actual usage from Eskom. So any discrepancies or deviations can now be flagged and also handled accordingly. But none of that happens if the availability of the data isn't there first. The availability is the foundation of the foundation, if we want to use the house analogy again. It's the first step in having a successful project. So it means that having the right data at the right places and also at the right time, but consistently. So in the energy sector, this is actually where most of the problems start. So you can have missing readings, delayed imports, siloed systems, and also incomplete streams of data. And if we can't rely on the data not being there accurately and on time, then we don't have anything solid to build on. So no availability, then we have nothing to transform, and essentially no fancy dashboards. So let's break it down even further and look at these specific availability challenges that we face every day in an energy project. So when we talk about the data availability challenges, we are talking about, like I mentioned, real day-to-day issues that impact every energy project. So it's about the operational data flowing from smart meters and SCADA systems and sensors, and also external inputs like utility tariffs and weather forecasts, and even fuel invoices. So together, all of these streams of data form a complete picture that you essentially need to optimize your performance and hit those ESG goals and ultimately control the costs. Yet, any delay or gap or even mismatch in one of them can bring the whole analysis to a stop and a halt. But here's the catch. While all of this data might technically be available, it's often not usable. So, for instance, the system you're trying to pull data from might be too outdated to work with modern applications. So, a legacy system, for instance. Some substations still rely on SCADA systems that is 30 plus years old, storing data in flat files still or on obsolete servers. And with the current shift towards cloud-based technologies and modern infrastructure, that rely on APIs and JSON strings, these legacy systems do present a major compatibility issues, and since they don't support API calls and often fall short of current cybersecurity and integration standards. And then next, it might be delayed hours or even days. So this can be due to slow networks or APIs that only update daily. And then also the inevitable meter maintenance. It occurs when meters get switched off for servicing or just load shedding, something that we are all very familiar with. And all of this can cause data gaps and interruptions in your data sets and your data availability. And then also another challenge is the data may be siloed. So it can be locked away in a department or system somewhere, requiring multiple access points and also access restrictions, and there's firewalls between applications, and then also just emailing multiple people over multiple days just to get to the right people, just to gain access to one system. And that can also take very long and be quite tedious. And then also, your data can also be incomplete and inconsistent, like I mentioned, due to power outages like load shedding, or one that's very important, lack of data ownership. So you can see there everyone is pointing to another person. So no one is clearly accountable and the responsibility gets shifted around. When that happens, errors can slip through unnoticed and meter gaps can go unresolved, and incorrect tariffs are applied across sites. And all of this leads to decisions based on assumptions rather than actual facts. And then lastly, data can also be misaligned because different systems speak different languages. So one system may capture the energy usage in megawatts per hour, the other one in kilowatts, and the third one in joules, with no standardization in place. So without the proper alignment between all of these systems and translating the data into a single source of truth, comparing and consolidating this data becomes very shaky and unreliable and also misleading. So at first glance, everything looks fine. The data is available, it is there, but the moment you try to use it for reporting or analysis or day-to-day decision making, it falls apart, like in the house analogy. The structure doesn't quite hold. So what you're left with isn't insight, it's unrealized data potential. And that's where the next step comes in. How do you unlock that data potential? And the answer is you unlock that potential through data transformation, turning those raw scattered inputs into a more structured and consistent actionable insights. So the question is, how do we bridge that gap between having available data and the challenges that comes with it to ultimately unlock the data potential and able to utilize it and reap the benefits of it?
So, Claudia, that's where, obviously, as you said, transformation comes in. And this is, in my opinion, where all the magic happens. So, transformation is the process of converting the raw, inconsistent, and fragmented data into something you can actually work with. So, a standardized, structured, and reliable format that's ready for analysis and reporting. So, that might sound simple, but it is one of the most complex phases in any data project. Okay, so you mentioned challenges like the inconsistent unit of measurement, the data gaps, silos, third-party data, and outliers, and so on. And with all of these in mind, we do need to address, first of all, what the aim of transformation is. So, what are we trying to achieve? Often people will view it as fixing the availability issues. However, that is not the case. Availability issues will unfortunately always be there. So you can mitigate them and you can try and manage them, but you will never have a 100% usable data set from the get go. So Transformation is rather data enablement. So using your data set with the gaps and the outliers from various units and from various silos, and trying to enable it via certain methodologies. Okay, so the question therefore changes to how do we enable our energy data? So we implement your ETL pipelines, so your extract, transform, load pipelines, and include built-in validation and cleansing logic. So we can start by just standardizing everything. So your names, your units, your structures, etc. So this can be done with various methods, but including like calculations and also conversion tables. Then, very importantly, you want to create a centralized source of truth. So you want to extract the data from the silos and ensure that everyone has access to the same data. And this is crucial because this will ensure that the insight between various departments will not contradict one another. Then it's important to clean and fill the data. So filling data gaps is actually a very fun part of the transformation process, because this is where any lack of process knowledge and a lack of creativity can lead to inaccurate data. So you want to apply algorithms that fill data gaps intelligently. And that means going well beyond your simple linear interpolation methods. So while they are quick and easy, they often ignore your real world context and system behavior. For instance, they do not account for operational shutdowns, non-linear usage during peak and off-peak trains, etc. So we use a more sophisticated technique and techniques that preserve your operational meaning. So these can include the following. So first of all, you can look at, for example, time-based pattern matching. So this is using, let's say, the same data pattern of the previous week, scaling it according to the gap we're looking at right now, to then fill that data. So this is typically very useful in routine operations that has sort of cyclical values and patterns. So yeah, that's that. And then we also have cluster pattern matching, where you use the data based on operational profiles. So that can include your weather or the state of your equipment. So you can, for example, say this first part is, let's say, when Crusher 1 was running, and the second part is when it wasn't running, and then it was again not running, and we used that pattern to then again scaled according to the values, and then just fill that according to a equipment state pattern. And then also very important to apply algorithms to also indicate when data should not be filled, because sometimes there are outages and the values are not necessary to or should not be filled. So you're not just filling the data for the sake of completeness, you are trying to restore its operational integrity. So that way, when someone looks at a report, they are not just seeing some mathematical guess, they are seeing meaningful, usable insight that mirrors reality as closely as possible. So this is an example of a filled report where the values are in red, the filled values are in red. So at the top, we have consumption values, and at the bottom, you have the meter readings that are accumulated values. So in this case, you can see this wasn't just with linear interpolation, otherwise your consumption would have been a straight line. So we used the time-based pattern matching, since we want to keep the time of use context, because for energy applications, for, let's say, cost allocations based on Eskom time of use tariffs. And then based on scaling the consumption values according to that, with that pattern, according to the gap size, you can see there's a smooth transition from the filled values to the actual values again. Another thing to note is the fact that the data points are highlighted as filled. It's not trying to be imitated as actual values. So the users of this report can trust what they are seeing, and they know exactly what is actual data points and what was filled via the system. Okay, then, so after your literal transformation has been done, so you've standardized your data, you've cleaned it, you've filled it, you have a single source, there's unfortunately still work to do. And that is that even when you do have good data and there's no workflow to approve or validate it, people can start question whether they can trust what they see. So, therefore, just as important as transformation, we embed approval workflows and manual forms to allow users to approve and approve the data and to have an audit trail. So this allows users to become custodians of their data and validate it before it gets published or reported on. So this inherently creates trust and accountability. So in short, transformation isn't just about cleaning up, and it certainly isn't about fixing your data availability issues because they will always be there. It's the behind the scenes work that turns your chaos into clarity and enables your data. Without it, everything that comes after your dashboards and your reports is built on a shaky foundation. And everything that comes before it is basically useless. Um, Good transformation ensures your data is dependable and that every decision that follows is based on solid ground.
Thank you very much, guys. One thing that I made a note of here, Tineke, I'm sure you said filling data gaps is the fun part. I'm sure we all get our kicks in our own ways.
Yes.
Um, but thanks for sharing all of that. I was wondering if I could perhaps follow on with some more detailed questions. So the first one is when we look at rolling out a project like this, there are obviously lots of technology that we can look at. Do you have any preferred or recommended tools or frameworks that you can suggest that would help us accelerate this data integration and standardization across various analytics and visualization projects?
So I feel like I can answer that question. So a framework that we've developed is it's called the Unified Data Management Framework. So this framework basically brings data from various sources like SQL databases and Excel files, party APIs and everything into a central trusted repository. So this framework can handle structured data, so data from SQL databases, and semi-structured like JSON strings, and also unstructured data from, let's say, from invoices that's in a PDF format where you can OCR it in and then extract those the data and the usage and everything from those invoices, whether it's remotely or on premise collected. And as I've mentioned, like it also allows for remote data collection. So whether it's external or internal, or located behind firewalls or everything, or disconnected environments, so scattered environments, this framework allows to securely transmit the data via gateways and message queues and everything to just securely move the data to a centralized storage space. And then to answer your question about the tools, so there are many tools available. It's dependent on what you specifically require. So if you require data collection and integration, then an example would be something like InMation or TIPCO. And if you would rather want visualization capabilities, then Connect and Pi from Aviva or IP21 or A1PE is applications that you can use. And then also, but if you need more of a human intervention and a decision making, if that's necessary, then there's a workflow tool for Flow, which is our own product, which allows for those real-time interactions and multiple approval steps, and which guides the user essentially. Thank
Thank you very
you.
much. So I think, Tineke, I think it was you that mentioned putting workflows in place so that data that's fixed through this automated channel doesn't just get absorbed into the system without at least some human eyes on it to make sure that nothing's gone wrong. My question there is, how do you build a workflow into the daily operations without that creating additional new bottlenecks in the process?
Okay. Yeah. So I did mention that. And I think we need to first look at the bigger picture. Is that the digital transformation projects in themselves are there to, first of all, reduce bottlenecks. So you want to prevent adding more bottlenecks as far as you possibly can. So inherently, you'll start by obviously reducing the bottlenecks in terms of users having to go and compile data sets and compile reports, and those will now all be automated, and those bottlenecks will already be eliminated. However, if you do add workflows and you do need that human intervention, there's obviously the risk of bottlenecks. So what you can apply in those cases can include escalation, so time-based escalation. If a workflow gets stuck and someone isn't acting on it, then it can be escalated to a higher up user or a different user, depending on your business rules. Or you can also just implement notifications. So also just pinging the person, telling them this data has to be approved, etc. Another alternative is to actually already display the data in the reports and whatever, but indicate them as unapproved, as if they had not yet gone through the entire process, so that the users of the reports can see the data, but they know that that's not necessarily already validated and approved. So those are some ways you can do that. And then another benefit of digitizing all of this, all of these steps and the data processes and everything, is you do have the option to trace these things. And if you have the option to trace these things, you can go back and you can investigate these bottlenecks and understand why these happen and where they happen, and then adapt from there. Try and understand how you can change your process and the workflow process to prevent these, or at least reduce them, and then to make a more seamless workflow going ahead.
Understood. So debottlenecking back directly into the process itself.
Yes.
Interesting. So I was wondering, uh, in terms of the various data sources we're talking about, so there was a mention at some point about structured and unstructured and time series data and third-party databases and all of these various sources. Do you have any best practices you can share with us today about how we blend this information into a coherent data structure that's useful for these analytic systems?
Yeah, so Charl, I think one thing that's very important is to have a flexible architecture, so a flexible UDM architecture. So this means that it's able to handle various data types and formats, and then also the frequency of data in and out. It should allow for seamless integration between these systems. And then also, everyone's heard the saying garbage in, garbage out. So, enforcing data quality at the ingestion. So, from the start. So, it's much easier to prevent bad data from entering the system than trying to change it and clean it after the fact. So this you can do by incorporating like various validation rules, and then also threshold logics, so min and maxes that guides the users, and then also having multiple approvals. So someone a bit more senior, supervisor, needs to approve an operator's information that they've put into the system before it actually gets committed to the database. And then also lastly, I think it's very important to make sure that there's at least a primary key that connects these two systems with each other. So whether it be a timestamp or a meter ID or anything, just to prevent the misalignment between the two systems. So I think that those are things that is a good practice to start with.
Understood. Prevent the swamp from occurring in the first place.
Mm.
All right. If we can move away a little bit from the technical aspects of what we're talking about here, and maybe discuss the adoption and change management side of things. In an environment where we have potentially not the best history with legacy systems trying to do similar things, how do you recommend organizations move towards overcoming historical trust issues in previous projects?
Sure, I'll answer that one. So I think it comes back to that slide you showed earlier on, or the two slides that you showed earlier on. So the first slide you mentioned the low success rate of these projects, and I think a large or a big contributor to that is the trust erosion. The users aren't using the systems, and obviously, if it's not used, it's being wasted. So I think already that shift from spending most of your time on the build phase, um, shifting that towards spending more time or a greater percentage of your time on both the requirements specifications and the design, as well as at the end of the project, the adoption and change management, will already bridge a big gap in that trust erosion from the get-go. I do think this is probably one of the biggest problems, is the users not wanting to change, not wanting to start using these new systems. So what I think would help is if you approach a project in phases. It's first of all, it's not as much of a information overload on the users. They start using small portions of the greater system to understand its bigger impact at the end of the day. And if they can also be included in the process of design and implementation to get feedback and to understand what their experience is like, I also think that can help a lot at the end with the adoption change management and reduce that load a lot. Making sure to take their ideas into consideration, and also, again, having a balance between what is practical and what is really going to enhance the user experience.
So, no, certainly. So I think there's many benefits of moving in sprints and waves, right? So at the end of a sprint, you hope to unlock value and you reinvest that value into the next sprint, etc., etc. So definitely benefits and in moving in that fashion. And then I think any project that's ever tried to exclude users from the conversation sits in that 85% of failures that we showed earlier. Speaking of failures, how do we validate these projects? If we look at the AI analytics tools that we're implementing in business today, do you have any meaningful metrics by which we can measure the success rate of these projects?
So, Charl, that's a very good question. So, in my opinion, to truly assess whether all of these AI and analytic tools are actually improving our day-to-day decision making, you need to ask yourself, um, are you getting to the right answer faster and with less effort, and also with greater accuracy? So, we have all of the answers to make decisions because we have so much data at our disposal nowadays, but it often takes just that few hours too long to get there, or and then it's irrelevant by the time we actually have it, or it just takes too many resources to get to the answer. So again, you need to ask yourself, does this tool or AI methodology reduce the effort and time to answer, and or is the accuracy of that answer that you're getting better? So it boils down to what I first said in my slides, that you have to establish what you want the outcome to be. So what is your end goal? You need to make sure that you essentially benchmark your as is of the project in the beginning phases, so when you are goal setting, and then try and understand what you want to achieve, so your to be, and then use specific tools that will help you essentially get there in the best way, so to achieve that objective. So again, the right answer faster with less effort and also greater accuracy. I think those measures are a good way to start.
Okay, so what we define during goal setting really becomes the metric that we measure against at the end of the day. So maybe just on that, when we think about the goals and the objectives that we are targeting with these types of projects, there are lots of data we can consume. There's lots of usages that we can put it to work with, but how do you structure a roadmap around which of those you start with and then sort of develop over time? How do you position those things to have early wins, like I mentioned earlier, where you unlock value to roll into the next project? Have you got some thoughts around that?
So Charl, I think that again goes back to your slides at the beginning. Spending a bit more time in determining what the requirements are, first of all, designing your solution accordingly, and then sitting with the users and stakeholders and really prioritizing these in an order of impact. So, what would now lead to the biggest benefits? So, I think that's something you have to have a long-term vision, but also a short-term vision. So, to sort of zoom in on what will have the biggest impact for the investment now, and then sort of start with your phase one as a proof of concept to understand whether this can work and whether this is going to be adding value to your organization. You can lay out your roadmap, for example, your phase one, your phase two, etc., phase three, up to wherever you feel is necessary. Also, number of phases will depend on how granular you want to make these phases. But let's say phase 1 to 4. And then once you've completed phase 1 and you are happy with the value it added, you can then move on towards the next ones. But both the client and the company who will be implementing the solution needs to be open for adaptation, because a lot of times as you work through, let's say, phase 1, you realize there are other things that can be more beneficial now after phase 1 than necessarily what you anticipated would be before you started with phase 1. So I think being able to adapt and willing to adapt is a very important part of this, but also, again, spending a lot more time on the design and the user requirement specification and understanding exactly what there is and zooming in on the highest value add from the start.
100%. Thank you very much. And I think with that, we've come to the end of our webinar. I think in a nutshell, we've looked at why goal setting is important, and understanding not only what we want to achieve, but also defining the metrics for us at the end of the day to measure ourselves by. We've seen in a lot of examples how making sure that the data we ingest and use and bring into our data platform, how important it is to make sure that all of that processing and cleaning and prepping is done before we turn it into a swamp, then how that makes the rollout of applications in terms of analytics and visualization on top of that data set so much easier. And we've also touched a little bit on the sort of crucial component of involving the end users. And if we ever want these solutions that we're building to be adopted and add value and change people's lives, we need to make sure that those people are involved in the process. So thanks, Tineke and Claudia, for sharing your insights with us. Thanks to the audience online for joining us today.